So in this video, we are going to start about colloids. See, colloids, they are heterogeneous system. Okay, we have studied that solutions, they are of two types solution, that is like one is the homogeneous and another one is heterogeneous. Okay, so colloids, they are heterogeneous systems. Solution is the example of homogeneous, but I'm explaining it just to for the knowledge that it is a heterogeneous system. Okay, colloids, they are heterogeneous systems, means that they solvent and solute, they are not very properly mixed, and the solute particles, they are larger in size. Okay, now colloids, they have they have two components. Those two components, that is dispersed phase, and another one is dispersed medium. There are two components of colloids, that is dispersed phase and dispersed medium. Dispersed phase is that part which gets mixed. Okay, and dispersed medium is that which dissolves the another component. We can say that dispersed medium acts as solvent. Okay, and dispersed phase, it acts as solute. In simple language, if we discuss, colloids have two components, dispersed phase and dispersed medium. Dispersed phase act as solute, and dispersed medium, they act as solvents. Okay, now on the basis of interaction between dispersed phase and dispersed medium, they are of two types. On the basis of interaction between dispersed phase, DP I'm writing, dispersed phase and dispersed medium, the colloids, they are classified into two types, that is lyophobic and lyophilic. Lyophobic and lyophilic. See, lyophobic simply means that which are water hating or liquid hating. Okay, means that in them they are firstly irreversible. Okay, and the interactions, they are very weak, very weak. Lyophobic, which means that liquid hating, means that in them the dispersed phase, that is very, very less soluble. Okay, soluble, or we can say very less interactive. And lyophilic is which are liquid loving. Okay, in them the dispersed phase has good interactions with the dispersed medium, and it is reversible. It can easily be reversed with different separating techniques, which we will study in the further videos. And along with that, these lyophilic, their example is starch in liquid. Okay, so lyophilic is liquid loving. Philic means loving. Phobic means phobia, hating, liquid hating. Okay, these are reversible, and its example is starch in the liquid. These are liquid hating. The interactions are very weak. Along with that, these are irreversible, and these are prepared by special methods. They are prepared by special methods. Okay, its example is metals in dispersed medium. Along with that, very important point, these lyophobic colloids, they are unstable, while these have higher stability than lyophobic. Like stability is not very high in lyophilic, but as compared to the lyophobic, these lyophilic are more stable. Okay, so this is the two types of colloids on the basis of interactions between dispersed phase and dispersed medium. Now we have to discuss a very important type of colloid, that is associated colloids. See, what are associated colloids? There are some substances which at low concentration act as electrolytes. Some substances which at low concentration behave as electrolytes, but at high concentration, when their concentration is high, at that time they show colloid behavior. Okay, they show colloidal behavior at a higher concentration. Okay, and how they show colloidal behavior at higher concentration? By formation of aggregates. Okay, by formation of aggregates they behave, they show colloidal behavior. Okay, and these aggregates, they are called as micelles. These aggregates are called as micelles. Now, this micelle formation, this aggregate formation, it happens after a specific temperature, above specific temperature, which is called as Kraft temperature. Okay, which is called as Kraft temperature. Km, with Km we denote it. And it takes place after specific concentration. Above particular or above specific concentration, that is called as critical micelle concentration. Critical micelle concentration, that is CMC. Okay, these micelles, they are formed of above particular temperature called as Kraft temperature, and above particular concentration, that is called as CMC, critical micelle concentration. Okay, now if we discuss about this structure of this micelle, what its structure is like, it has two parts, that is RCOO negative and Na positive. They are made up of like this. Okay, if we discuss, see, Na positive, it will be easily removed. RCO negative, and this R, this is the long hydrocarbon chain. This is long hydrocarbon chain, which is hydrophobic. Means hydrophobic means it is water repelling. And this CO negative, it forms a head, which is the hydrophilic polar head. Its structure is like this. That is shown like this. See, this is that R group. Okay, this one, which is hydrophobic long hydrocarbon chain, and this structure, it represents the COO negative, which is a polar hydrophilic head. Okay, so this is the structure of that micelle, which takes place after this Kraft temperature at specific concentration, that is critical micelle concentration. Okay,